Hello friends. Now we are going to discuss about how to implement a stack using a linked list. So stack is a linear data structure in which data which is inserted as well as deleted from one end of your stack, that is nothing but a top. So this is the top of my stack. So all the data which is inserted as well as deleted from this end of my stack. This is called as a last in first out operation. So whatever the data which is inserted at the end, that was comes out first of the stack. So if I insert a data like 10, then 20 will be inserted on top of the 10, 30 will be inserted on top of 20, and if I want to insert 40, it is inserted on top of the 30. So this is called as a push operation. So when I want to delete a data or when I want to remove a data from stack, the top element will be removed. That is means 40 first will remove, then 30, then 20, and then 10 will be removed. That is nothing but last in first out operation. Now we want to implement this stack with the help of a linked list. To implement a stack using linked list, we can use a single linked list. So single linked list is sufficient for performing the push and pop operation as well as displaying the data of the stack. So here I have just declared a node structure which we are going to use for implementation of a stack. So every node of the stack is consist of 2 points. First is nothing but data and second is nothing but its next pointer. In case of linked list, we are declaring a start as a first node of our linked list. The same way, in case of your stack, all the operation, that is nothing but insertion as well as deletion operation, is done on one end, that is nothing but the top of the stack. So here we are declaring a top of the stack as a null. The reason is that when the top of the stack is null, that means your linked list is empty. That is nothing but your stack is empty. So this node structure we are going to consider for implementing a stack. Let us start with the first operation, that is nothing but the push operation. So when I want to perform the push operation, that is nothing but inserting a data into the stack, first I need to create a node. So for creating a node, I will going to allocate some memory for that node. After that, I will read the data for the new node and I will assign the data to that new node. So when you want to perform the insertion operation, or we can say the push operation, there are two possibilities. So case one is nothing but your linked list is empty. In that case, you want to perform the push operation. And second is your linked list, or we can say the stack is not empty and you want to perform the push operation. Let us start with the first case. The first case is nothing but your stack is empty. How to decide your stack is empty is nothing but if your top is equal to null, you can say that your stack is empty. So when your top is null, that means whatever the new node you are trying to add, that new node become the first node of your stack. So that new node become a new top of your stack. So for that reason, I need to give a statement like top equal to new node. So that new node is assigned as a new top for my stack. And one more thing I need to keep in mind is nothing but we have to set its next null. So that was the second statement is given, that is new node next equal to null. So this was a case when your stack is empty. That means you are checking to your top is equal to null. If top is null, you can say your stack is empty. So whatever the data you are trying to insert, that new node become new top of your stack and its next become null. Second case is nothing but your stack is not empty. That means just assume that your stack is already holding a data 10 and now you want to add a data 20 on top of the stack. So in that case, this 20 is added on top of the 10. So when you are performing the push operation in case of stack, you have to use the concept of insertion at the beginning. So you can check here, I want to insert this new node above the 10. That means this 20 should be present before 10. That means I am trying to perform the insertion at the beginning. So for that reason, I am writing new node next is equal to top. That is after 20, this 10 will be present. Its next will remain null and new top become 20. So you can check here, 10 is already present in my linked list and I want to add this 20 on top of the stack. So now I need to create a link from this 20 to 10. So for that statement is given new node next is equal to top. Now this 20 is added on top of the stack. So I need to update the top with the value of new node. So top equal to new node, that statement is given. Now assume that I am trying to perform third push operation. I want to push data 30, that is nothing but new node 30, into my existing stack. So stack is already holding a two value, that is 20 and 10, and 20 is my top of the stack. So after insertion of 30, that means I need to first create a link from this 30 to 20. So for that statement is required new node next is equal to top. And after that, currently 20 is top of my stack, but now 30 become top of the stack. So I need a statement top equal to new node. So your 30 become new top of your stack. So that's all about push operation of a stack. Now check for the pop operation. Pop operation is nothing but we are trying to delete a data from top of the stack. So when you want to perform delete operation from top of the stack, there are two possibilities. First is nothing but stack is an underflow case. That is nothing but your stack is empty and you are trying to perform the pop operation. And second case is nothing but your stack is not empty and you want to perform the pop operation. So let us discuss a first case. So first case is nothing but we are checking for the stack underflow. That means your stack is empty and still you are trying to perform the pop operation. So how to check stack is empty? So if your top is equal to null, you can say your stack is empty and it is not possible for you to delete any data from your stack. That is nothing but stack underflow condition is occur. Now second case is nothing but your stack is not empty, it is already holding some data, and in that case you want to perform the pop operation. So there is a first pop call is done. In that case what happens? This is my current status of my stack. So when I go for calling this pop function, at that time top element, that is nothing but 10, will be removed, and after that new top of my stack that become 20. So for that, I will first hold a data of 10 into a temporary variable. So I will take a temporary variable and hold a data of the top. After that, I will update the new top by temp next, or I can update with top next. So this 10 can be identified as a temp as well as by top. So I can update the top as a top is equal to top next. After that, if you want to print a data, you can print a temp data so that you are able to find out which data is deleted from top of the stack. So in that case, 10 will be the output you can print. After that, whatever the memory which is allocated for this node 10, we want to free it. So for that, free temp, this call will be given. After performation of this pop operation, your stack status will be like this. So again, if I want to perform the pop operation, now my top is 20, so it is removed from and your 30 become new top of the stack. So now your top is pointing to 30. Suppose I again go for calling one more pop function. In that case, your 30 will be removed from the stack. And when you go for taking top is equal to top next, in that your top will be set with the value null. So if I go for again one more call for the pop function, in that case what happened? Your top is set to the null, your if part will be executed and you will get the output stack underflow. That means your stack is empty and it is not possible for you to delete a node. So this is about how the pop operation will be done in case of your stack. Now let us check for the third operation, that is nothing but a display operation. I want to display the current status of my stack. So here for display again we have the two possibility. We have to first check your stack is empty, that means it is in underflow condition or not. How to check it? You can check it with the help of top equal to null. You can print it your stack is in underflow condition. So second case is nothing but your stack is not empty and you want to perform a traversing operation. So I will just take one pointer for traversing this stack and it will start from top of the stack. So I will hold the temp with the top value. We'll check for temp is equal to null. So currently temp is holding a data 30. So when this condition, that is while condition, become true, and it will print a data with the help of temp data. So temp is 30, so 30 data is printed. After that, I will update my temp pointer. So now my temp is pointing to the 20. While loop will be executed, we will print a temp data, that is nothing but 20 is printed, and temp will be updated with the temp next. So it will update to the 10. So now my temp is pointing to the 10. Again while loop will be checked. So while 10 is not equal to null, condition satisfied, I will print a temp data, that is nothing but 10 will be printed, and my temp is updated as a temp next. So now your temp become null since the temp is the bottom element of your stack. So its next pointer is null. So when we go for this while condition, this condition will fail and we will come out of the loop. So now you can observe first 30 value, then 20 value, and then 10 value will be printed. So that's all about how to display a stack element with the help of linked list. Hope so you like this video. If you like this video, please don't forget to subscribe my channel. Thank you.